Here we will be looking at our laws of exponents and how to simplify the following expressions. You want to make sure you remember all your answers need to have positive exponents. Don't leave any negatives. So on number 24, the rule says if you have the same base and they're divided, you can keep the base and subtract the exponents. So I kept the 3, 6 minus 4 is 2, and that is 9. On number 25, this rule says if you have a power raised to a power, you multiply those exponents. On number 26, it's just an extension of number 25. We're going to multiply the exponents, but the most common mistake is not distributing or multiplying that exponent with that number of 3 raised to the first power. So this is 3 to the third power, x to the 12th, and don't forget to multiply down here, and we have y to the 24th. Simplifying that, that's 27, x to the 12th, y to the 24th. On number 27, we have a fraction. So we're going to kind of go back to the rule where if you divide with the same base, you keep the base and subtract the exponents. But we also want to remember, how do we reduce fractions? Well, 3 goes into 39 13 times. That's the same base, so keep the x, subtract the exponents, that's a 1. The y's are the same, keep the base, subtract the exponent. Now that's okay. A lot of teachers don't like you to put that 1 there. It's just understood. On this one, what does this rule say? If you have the same base that is being multiplied, you keep the base and you add those exponents. So 6 plus a negative 4 is 2, which again is 9. Here, remember there's a 1 there. We want to multiply all those exponents. That's 2 to the third power. X is still to the 0 power. Y to the 9th. Don't stop there. That's 8. Now do you remember what that is? Anything other than 0 raised to the power of 0 is just 1. So we're just multiplying by 1. And then 8 times 1, of course, is 8. Here, again, we can distribute. We have x to the negative 6 and y to the negative 15th. But the directions say I cannot leave my answers with negative exponents. So how do I make negative exponents into positives? You take the reciprocal of their bases and change the sign of your exponent. Here I'm going to distribute. I have x now to the positive 16th and y to the negative 12th. That can't be in my final answer. So the x to the 16th is positive, so it stays, but the y to the 12th moves to the denominator and then has a positive exponent. 32. We want to reduce, but all those negatives. You know, before I do anything, I'm just going to make them all positive exponents. So I'm going to take this x to the negative 2 and move it downstairs, and move x to the 10 upstairs. Now y to the 6 is already positive, so it's going to stay, but that one needs to move upstairs and becomes a positive 3. Now I can reduce that by 7. So let's see, 7 goes into 14 2 times, 7 goes into 21 3. That's being divided, so keep the base, subtract the exponent. That's being multiplied, so keep the base and add the exponent. 33, I'm going to do the same thing. I'm going to keep the negative 9 and 12, the x squared and the x to the 4th. But this, I'm going to move downstairs, and this, I'm going to move upstairs. Now you might say, why didn't I move that? It's not a negative exponent. It's just a negative number, so it stays where it is. But I can reduce that. That's negative 3/4. Now how do I reduce that? Since there's more x's on the bottom, I'm going to keep my x on the bottom and subtract 4 minus 2. There's more y's on the bottom, so I'm going to keep the y on the bottom and subtract 8 minus 4. just go over those 3 or 4 rules of exponents. When do you add them? When do you multiply them? When do you subtract them? What's the exponent of 0? And how to make a negative exponent into a positive exponent. The next part is adding, subtracting, multiplying, and dividing polynomials. So we really need to look at those indicated operations. So if we're just adding, that just means we're adding like terms. So those parentheses really don't do us any good. So I'm going to collect like terms. That's 8x squared, that's minus 8x, and minus 8. I think that's purely coincidental that those are all 8s. Now on number 35, that minus makes a huge difference because that minus has to be distributed before we can collect like terms. So that becomes plus 8x plus 2. Now put those together. That's 4x squared, that's plus 7x, that's plus 8. So this is the one you really need to be careful of. Here we're multiplying. So I'm going to use the FOIL method, first out, enter last. So that's going to be 18x squared minus 15x plus 48x minus 40. Collecting like terms, that's going to be plus 33x. We're not factoring, we are multiplying. Same thing here, I'm going to multiply. I'm going to use that FOIL. So I have x squared plus 11xy minus 11xy minus 121y squared. You should have recognized that that is the difference of two squares. So when you multiply that together, you are going to get the difference of two squares. Now we're going to look at division. We're either dividing by a monomial or by a binomial. If it's by a binomial, you have to use long division. If it's a monomial, you can just separate them into different fractions. So you have 24x to the 5th yz divided by 3x to the 4th yz squared plus 6x to the 4th y squared z cubed over the same denominator. And continue. And I hope I don't miss any exponents. Now I can reduce each part. So 3 goes into 24 8 times. That reduces to x. Y divided by y cancels out. And just like I did above, the z's, there's more z's on the bottom, so I'm going to keep the z on the bottom. 2 minus 1 is 1. Then 6 divided by 3 is 2. Those cancel out. The y's keep the base, subtract. The z's keep the base, subtract. Then a 4 and 3 do not reduce. I have an x squared, a y squared, and a z cubed. So those are really ugly answers. On number 39, same thing. So separate them, then reduce. So let's see, 12 and 8 are both divisible by 4. There's more x's on the bottom, so keep the x, subtract. There's more z's on the top, keep those and subtract. That goes in there 5 times. Keep the x and subtract, that cancels. Let's see. Ooh, now that all cancels out. So is that 0? No. We're dividing. 8 goes into 8 one time, one time, one time. That's just 1. So really, how would we really write that answer to make it pretty? We wouldn't write it as fractions. You'd leave the first one as a fraction. But that's really, I guess, the best way to write that. But make sure that you did not make the 0, that you made it a 1 because you're dividing. The next two, because you have a binomial, you need to use long division. So we set that up. And remember, we divide those. Then we're going to multiply. And then the way I teach is I teach my class to draw the line and change the signs. That's the same as subtracting. Those should always cancel. If they don't, you've made a mistake. And then repeat the process. You're dividing the first two, and that goes in there plus 5x squared. You're then multiplying, again, this times what's in front. I'm going to draw my line and change the signs. Those should cancel. And repeat. X divides into x one time. Don't quit. Draw your line, change the sign. And so your remainder is a positive 3, and you put that over your divisor. So your final answer is 2x squared plus 5x plus 1 plus 3 over x plus 4. Let's do that again. So we have 4x minus 1 into this polynomial. Okay, so divide. That goes in there 3x squared. Multiply. Draw your line and change that sign. Again, that's just subtracting. Bring down your next term. Repeat that process. Draw your line. Change that sign. Again, divide. That's minus 8. Draw your line. Change the sign. Or just a 2, I guess. But I'm going to put plus 2 over 4x minus 1 up here. Now again, I know this is fast, but this is also should just be a review. So what we just did was we divided polynomials two ways, with long division and monomial division. We multiplied polynomials, and we added and subtracted polynomials.